Hey there, science explorers! Today, we're diving into the exciting world of tensile testing. Imagine you're a superhero testing your powers. You need to know how much force you can handle before things get, well, stretchy. That's what tensile testing is all about, figuring out how strong a material is when we pull on it. Now you might be thinking, tensile testing sounds complicated, but trust me, it's not as scary as it sounds. In fact, it's pretty cool once you get the hang of it. We use tensile testing for everything from designing bridges that won't buckle, to making sure our phones don't snap in half. So put on your thinking caps, grab your notebooks, and get ready for some serious tensile fun. We're about to unlock the secrets of material strength, one pull at a time. Remember playing with rubber bands as a kid? You stretch them, you twist them, you launch them across the room. Don't lie, we've all done it. Well, guess what? You were basically doing a mini tensile test. Think about it. When you pull on a rubber band, you're applying a force that tries to stretch it out. The rubber band resists that force, trying to return to its original shape. This push and pull is what tensile testing is all about. Now imagine you keep pulling and pulling on that rubber band, eventually it reaches a point where it can't stretch anymore. Snap! That, my friends, is called the breaking point, and knowing this point is super important for engineers and scientists. So next time you pick up a rubber band, remember, you're holding a tiny testament to the power of tensile testing. Alright, science whizzes, it's time to learn some fancy tensile terminology. Don't worry, I promise it's not as intimidating as it sounds. Let's break it down. Test piece. This is our VIP, the material we're testing. Think of it as the star of our tensile show. Gauge length. Imagine drawing two lines on our test piece before we stretch it. The distance between these lines is the gauge length. It helps us measure how much our material stretches. Elongation. Remember how our rubber band stretched? Elongation is simply how much longer the gauge length becomes after we pull on it. Stress. This is the force we apply to our test piece, like when we pull on that rubber band. It's like the pressure our material feels. Strain. Strain is how much our material changes shape under stress. It's like measuring how much our rubber band deforms when we pull on it. See? Not so bad, right? Now you're one step closer to becoming a tensile testing pro. Every superhero needs a trusty sidekick, and our tensile testing superhero is no exception. Let's meet the amazing tools that make it all happen. Tensile testing machine. This is our heavy lifter. It applies a controlled force to our test piece, like a super strong robot arm. Grips. These are like the clamps that hold our test piece in place, making sure it doesn't fly off when we apply force. Extensometer. This clever device measures how much our test piece stretches, giving us precise elongation data. Computer, our data cruncher. It records all the important information from the test, like stress, strain, and breaking point. Together, these tools form the ultimate tensile testing team, working in perfect harmony to reveal the secrets of material strength. Section 5. Tensile Tango, the step-by-step. Ready to see tensile testing in action? Let's break down the process, step by step. First, we carefully prepare our material, making sure it's the right size and shape for testing. Next, we carefully clamp our test piece into the grips of the tensile testing machine, like fastening a seatbelt. The machine slowly starts pulling on the test piece, increasing the force over time. The computer diligently records the stress and strain values as the material stretches. Eventually, the material reaches its limit and breaks. The computer notes the force required to break it. And there you have it. We've successfully completed a tensile test, uncovering valuable information about our material's strength and elasticity. Section 6. Remember this. Handy tips for tensile triumph. Memorizing all these terms and steps can feel overwhelming, right? Don't worry, I've got your back. Here are some memory tricks to make it stick. Stress is what you feel during exams, and it makes materials strain or change shape too. Imagine a rubber band or test piece being stretched between two hands, or grips. That's tensile testing in a nutshell. Remember the acronym STRETCH. Stress, test piece, record, elongation, tensile machine, clamp, history, or data. Use these fun tips to keep those tensile terms fresh in your mind. You'll be acing those exams in no time. Section 7. Real-world tensile tales, from bridges to bungee jumping. Tensile testing isn't just some abstract concept, it's everywhere. Let's explore some real-world examples. Bridges. Engineers use tensile testing to ensure bridge materials can withstand the enormous stress of cars and trucks. Airplanes. Aircraft wings undergo rigorous tensile tests to ensure they can handle the forces of flight without breaking apart. Bungee jumping, yes, even your bungee cord goes through tensile testing to make sure it can handle those exhilarating plunges. These are just a few examples of how tensile testing helps us build safer, stronger, and more reliable structures and products. Section 8. Tensile Testing, your ticket to success. Congratulations, science superstars. You've successfully navigated the world of tensile testing. You've learned the lingo, met the tools, and even discovered real-world applications. Remember, understanding tensile testing isn't just about acing exams. It's about unlocking a deeper understanding of the materials that shape our world. So keep those brains buzzing, keep asking questions, and never stop exploring the wonders of science. Section 9. Keep exploring the world of materials. This is just the beginning of your materials science adventure. There's a whole universe of fascinating properties to discover, from compression and torsion to fatigue and hardness. So what are you waiting for? Grab a book, watch a documentary, or even try some hands-on experiments. The world of materials is your oyster. Go explore it.